Good morning, everyone. Welcome to our virtual pre-lab lecture. Uh, First, I apologize for those who were waiting for an invite this past Monday. I remember I sent out an email that there will be uh, an email coming to you regarding on how to join the Zoom lecture. For some reason, the system didn't send the invite automatically when I opened the conference. It should automatically invite you to join the conference that it has started. However, it didn't happen this past Monday. I hope you are able to watch the recording. I did post the recording for what we did on Monday and the assignments which you had to do and complete before the due date posted. If you didn't complete those assignments, if you missed the first session this Monday and you haven't done anything, please let me know after today's session, so that I can extend the due date for your assignment. Okay, there were assignments which were due this past Monday. I mean midnight. You are supposed to complete a quiz. There was a quiz on safety rules and the safety contract. I don't want to waste my time. I just want to dive straight to our discussion today. That is the lab on measurement and uncertainty. Measurement is not something new to you, even though you may have seen it before or you may have not taken any chemistry course. You know what measurement is, but we will fine tune to what chemists really mean by the word measurement. When we talk about measurement, a measurement consists of two things. All right. When we say measurement, it should have two things. All right. Measurement, it should consist of a number and a unit attached to it, a number plus a unit. Otherwise, with no unit in chemistry, there's just a meaningless number. All right. I can say the distance from here to Miami is 358. If I say 358 with no units attached to it in chemistry, in science, this is a meaningless number unless you attach a unit to it, and then this now makes the number a measurement. All right. In chemistry, every time you have to record a measurement, you should include units attached to it. Otherwise, it just be a meaningless number. So remember that all measurement must have a number and a unit attached to it. Now, there are three systems of measurement. We have what we call English. All right, there is English. There is the metric. All right, and there is the SI Unit System International. You have covered that. System International. These are the three systems of measurement you should be familiar with. You should be able to distinguish. When we say English, you may think that it's used in Britain, but it's used here in the US. All right. Somebody's asking a question. Hold on. Ashley. Oh, GM4, good morning. All right, thank you. I got it. Thank you. All right, thank you, everybody. I got the GM4, good morning. All right, Deborah, thank you. So coming back to my whiteboard here, you should be able to distinguish, understand that there are three systems. One, English, we use here in the US, for example, when we say mouse, we are talking about the distance. Columns, all right? Every time you pulled by the car station. The gasoline is dispensed in gallons, uh, ounces, all right, pounds, for example. We use all these in everyday's life. These are English units of measurement. And then in school, we use the metric system. And this includes such things as gram, wherever you measure the mass of reagent, the units are in grams, or maybe milliliters. Liter is a metric system, or maybe if you talk about the distance, all right, use meter. These are the common unit of measurement you will see in metric system. Kilogram, there is milliliters, and so forth. Are we supposed to see the white? Oh, yes. All right. Let me see. I thought I shared this with you. Let me share that. Yes, thank you. You're supposed to see the whiteboard. All right. I'm going to show you the whiteboard. This is the whiteboard. Thank you. For some reason, I thought you were seeing the whiteboard. That is the whiteboard I'm talking about. The whiteboard is on my right side. You can see on your screen, this is the whiteboard. I'm talking about the three systems: mouse, columns, ounces, pounds, and grams, liters, meters for this is meter, this is liter, and this is gram for metric. SI units for volume, we're going to talk about maybe meter cubic, maybe kilometer, and so forth. These are the SI unit. I don't want to spend more time on the three systems. You can read on those. I'll leave that to your lecture instructor to go through, but just to give you an overview that you will, there are three systems and you should be able to know which one is which. We are going to be focusing on this. This is what we use in the lab, and throughout the course, measurement will be in metric system. And the advantage of this over English or SI is you can expand or you can reduce the base unit using the prefixes, kilogram, gigameter, and so forth. Those are the prefixes used to expand. You cannot expand this, you cannot expand the SI unit, in today's lab, in measurement, the three, or rather the system of measurement you will take note of is one, temperature. You're gonna take mass. This is what we will be measuring, temperature, all right, in degrees Celsius. And there is what we call the derived density. This is the derived unit of measurement in grams ml. These are the three measurement we will measure in today's lab on measurement and uncertainty. There is a term here associated with measurement. It's shows the degree of inexactness of a measurement. All measurement has some degree of uncertainty. All right. So all measurement consist of certain digits and one and certain. All right, the last digit in a measurement is always an approximation. It is always an approximation. All right, there's an approximated digit. a measurement of say 98, say 98, 98.6 degrees Fahrenheit. This last digit is always an estimate, all right? There is a degree of uncertainty. The first two are uncertain. So not all instrument will give you exact or exact or true value. There's some degree of uncertainty, and we'll see today how to report a measurement with the degree of uncertainty. The objective of this lab is to determine the uncertainty with standard classware. Hopefully, you have received your lab kit. All right, to do the measurement lab using the graduated cylinder, the LML flask, and 250 ml beaker. You should also determine the accuracy of measurement with standard classware. Accuracy, how accurate it is. When we say accuracy, this means how close are you in your measurement to the true value? All right, how close are you to the true value? There is accuracy and there is the precision, which you will have to measure that. Now, before we look at the experimental setup, I want to look at the concept of significant figures before we look at how to complete today's lab. I want to look at the concept of significant figures. Throughout the lab, all right, throughout this course, you will be multiplying numbers, you will be dividing numbers, all right, you will be adding numbers. And it does not mean all the digits you see on your calculator are always true. No, you may have more than what you need to record your final answer. All right. To record your final answer, what you need to do is learn and understand the concept of significant figures. Significant figures, and there are rules for counting significant figures. You count from left to right, all right? The rule is you count significant figures from left to right. And there are rules for, all right, counting significant figures, rules, all right? Rules for determining sig figures, all right? How do we go about counting the number of significant figures? Rule number one is all non-zero, all right? All non-zero digits, count, all right? They do count as significant digits. For example, here, if I have a number such as 187 8 grams with this mass, of, we count significant figures from this and 1, 2, 3, and 4. So this is 1, 2, 3, 4, and we say this has 4 significant figures. That's how you count. All non-zero digits do count as a significant or count as significant digits. All non-zero do count as a significant digit. Now, that is easy. Where it's tricky is when you are dealing with zeros. Zeros, sometimes they do not count. Zeros, sometimes they do, and you gotta be careful with zeros. How you look at zeros, sometimes they do not, all right? Sometimes we do not count zero, sometimes we do. Let's see how zeros do count. We have what we call leading zeros, all right? Leading zeros, they do not count. They are not significant what? Significant figures. They do not count as significant figures. How do I know that these are leading zeros? Zeros such as this number 0.018 centimeters, for example. These are called leading zeros, all right? These are leading leading zeros, and they do not count. So you'll start counting from the first non-zero digits, that this is one and this is two. This has two significant digits. You cancel out. Look at how I'm canceling out the leading zeros. Leading zeros do not count as significant. Do not count as significant. So you got to know what leading zeros are. Now there is captive zeros, all right? Captive zeros here, number three, captive zeros. These are zeros in between non-zero digit, all right, or digits for that matter. They are captured in between. That's how I look at it. For example, here 108 millimeters, 108 millimeters. The zero here is captive zero, and this number here has three significant figures, three significant figures. I can have a number such as 200,098 grams, for example, and the zeros in between these zeros right here, they do count as significant digits. So this has 1, 2, 3, 4, 5, 6. These are six significant digits, significant figures. So we count what? We count significant. We count significant. We count these zeros, the captive zeros, as significant. You have to know the leading zeros different from the captive zeros. Now, the last type of zeros, you got to be able to identify in a number are trailing what? Trailing zeros. Trailing zeros do not count unless there is what? There is an implied decimal point, unless there is implied decimal point. This is a trailing zero. If I have 1, 0, 0, 0, I don't see any implied place of decimal. This has one significant what? One significant figure. All right. A number such as 1, 2, 3, and 0, 0, 0. All right. This has three significant figures. There is no implied place of decimal. There is no implied place of decimal. However, if I rewrite the same number or same numbers with an implied place of decimal at the end, this will now count. All the zeros here do count. 1, 2, 3, 4. This has 4 significant figures. So these are 4 significant figures. The other one, 12 3 zeros, that is 1, 2, 3, 1, 2, 3, and an implied place of decimal. This has 1, 2, 3, 4, 5, 6. So this has 6. All right. This has 6 significant figures. Significant figures. Say 6 significant figures. So implied place of decimal should be there for trailing zeros to count. Otherwise, they will not count if you don't see any implied. They do not count if there is no implied place of decimal. Be careful when dealing with trailing zeros. They should be implied place of decimal to count. Now, there is a number in scientific notation. If a number is given in scientific notation, this is rule number, this was 4. Rule number 5 here, 5, a number in scientific notation. If a number is expressed in scientific notation, notation, all the numbers on the left side of the multiplication sign, I can have that seconds. For example, all the numbers on this side of multiplication sign do count as significant. Anything on the left side of the multiplication sign count as significant. So this has 3 significant figures, 3 significant figures. I can still have the same, all right, 1.2 times 10 raised to 6 seconds. This has 2 significant, all right. We say that this has 2 significant figures, 2 significant figures. All right, scientific notation. You know what scientific notation, a number expressed in such a way that it lies between 1 and 9. We say that number is in scientific notation. And lastly here, rule number 6 here, exact numbers do not count, or you don't subject the exact numbers to rules of significant figures. In other words, numbers obtained as a result of counting are considered as exact numbers. What do I mean by exact numbers? There are some numbers which you don't need any instrument to determine that number. For example, if I say I have 24 students, if I have 24 students in my class, the first, that is 2 and 4, somebody might say, all right, this has 2 significant figures. No, this number 2, 4, 24, I had to count 1, 2, 3, 4, 5, 6, all the way to 24. I had to count. So numbers obtained as a result of counting are exact, and we do not subject those numbers to significant. We just say infinite, all right? They do not have, or we don't say 2. If someone asks you that, just say that that is unexact. 7 days, all right? You have to count 1, 2, 3 day, 1 day, 2, you have to count. So 7, you cannot say that 7 days has 1 significant, because it is an exact number obtained from counting. 4 quarters in a dollar, that means you have to count 4 quarters. You don't need any instrument to measure 4 quarters, all right? You have to count. Divination also, all right? Divination, we do not subject these to rules of significant figures. We don't. So, such as 1 liter equals to 1,000 ml, 1 kg equals to 1,000 grams. These are divination, and we do not subject these as well to the rules we looked at from the previous examples, rule number 1 through 5. Just to mention to you, so that if you come across numbers obtained as a result of counting, you don't do that. So is there any question on the rules? You can use any resource to review those rules for counting significant figures. I want to just move to calculation and significant figures. Calculation and significant figures. Calculation and significant figures. When you carry out some calculation with your calculator, you'll end up with more than the required digits to express your number. You should go with the rules of significant figures. And I'm going to split into two the types of calculation you will encounter. We will limit ourselves to addition, all right, and subtraction. Means subtraction and multiplication, you know that, and division. All right, this is only these are the two categories I want us to look at. How you going to report your final answer? There is rule for these two, and there is a rule for these two here: multiplication and division. Multiplication and division. Let's start off with here, addition and subtraction. In this category, I will look at, you may want to make your road notes, places of what? Places of decimal, places of decimal. The least number of places of decimal, least number of decimal places determine how many places you'll have in your final answer. For example, here 12.01 plus 2.333. If I'm adding these two, your calculator will give you 14.343. This is more than what you need for your final answer. If you look at the first one, this has what? This has two places of decimal, not two significant figures. This has three decimal place, and the final answer should have two places of decimal. And remember rounding off. Remember the rounding off concept. If this is greater or equals to 5, we increase the preceding number by 1. Otherwise, we'll just drop the non-significant. We will drop the non-significant whatever is coming in there. So this will be 14.34. This is 14.34, and of course you have to include the units. Let me back up. You look at the places of decimal, wherever you are dealing with, this is subtraction. I meant to say this is subtraction. It is not division. That's what I'm gonna be looking at. Places of decimal. If I didn't have any place of decimal, then final answer will have no place of decimal. Say 12 plus, this was 3, all right, 2.333. You will see 14.333. This has a 0 place of decimal, all right. This has 3 place of decimal or decimal place. So our final answer will have no place of decimal. Just gonna stop there. We also look at that, and it's less than 5, and we just express the number as 14, not 14.0, not 14.0. All right. So final answer will have no place of decimal. If they have the same number of places of decimal, doesn't really matter which one you use. It will just go with that. That is what will be your final answer. Will be your final answer. And then here, rule number 2 here is multiplication and division. Here you look at the number with the least, all right, least decimal, no, least significant, least significant what? Least significant, least significant figures, least significant figures. All right. So I'm gonna look at that and make sure that you know, all of them have least significant figures. Like here, 2.3 times 1.387, for example. Let me put centimeters, centimeters in there. If I multiply using my calculator, here, let me just real quick, 2.3 times 1.387. I see here 3.19001 centimeter square. You just have to multiply the units as well. This has more than what we need. So how do we go about with that? This one has 2, all right? This one has 2 significant figures. This one has 4 significant figures. So our final answer should have 2 significant figures, 2 significant figures. So I'm gonna count here 1, 2. I will stop right here. This is greater than or equals to 5, and the final answer should be 3.2 centimeters square. You go with the least, all right? You go with the least. If you are dividing numbers, for example, density is mass over volume. If the mass is 1.00 grams and volume is 7.8, all right, ml. If you divide this, this has 4 significant figures. This one has 2 significant figures. So the final answer should have 2 significant figures. 10 divided by what? 7.8, and that is 1.28205 grams per ml. This is more than what we need. It's gonna be 1.3 grams per ml. You're gonna do that. For division, look at the least number of significant figures. You're gonna have this type of calculation in today's lab. Any question on significant figures? Any question on significant figures? All right, let's move on now and see what you need to look at in terms of the lab. Let's see, there are 3 parts. When reading a class, well, let's just zoom this. I'm just gonna increase this so that you look at the data sheet, all right? This is the data sheet on my left side and the procedure. I want you to read the background. I'm not going to read each and every statement in the handout. You can read the procedure, but the point here is you should be able to read the class where you will be using with the correct uncertainty or with the correct places of decimal. For example, in reading the volume, maybe the volume lies in between each one of them or in between two numbers. How will you figure it out that? You have to look at or count the places of decimal or lines in between two. For example, here I see the main subdivision between 6 and 7, that is 1 ml. That is 1 ml. If you want to know, all right, if you want to know what what does each one line represent, you will count how many of them there are in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. That's how you determine how many or what does each one small line divide. You have to count how many there are in between two readings. It could be a ruler. All right, you will do the same thing. So this will give me this value 0.1 ml, 0.1 ml of what? 0.1 ml. So if the volume or the meniscus is somewhere here, I'll say 6.1. If there are two, 6.2, 6.3, 6.4, and 6.5. Do not assume that always it is 0.5 when you are halfway. You have to do the math just the way I did. You subtract the main one and say, all right, this is what it is. And always volume measurement should be up to one place of decimal. I've seen rule of thumb whenever you're using graduated cylinder, whether it is 10 ml or whether it is 50 ml, you have to record the volume to one place of decimal, which will be plus or minus. Now, you will determine two types of errors, absolute and relative error. Absolute is the difference between the actual, that is the true value, and the measured value. And relative is the measured or the difference between the actual and the measured over the actual or true value. Accepted value, actual is the same thing, and multiplied by 100, that will give you the percent error for your calculation. Now let's see, I've gone through this concept of significant figures. By the way, you have to go back again. I know there are no work example relating all this. Please read on that and make sure that you are familiar with the rules. Here are the materials. If you haven't received your lab kit, I'm gonna take a poll later on so that we know where we are. These are the class where you will need. Like I said, please check, make sure that the checklist they put it in the box has everything they are saying it has. If not, you need to call the customer care and they will mail it to you. So you're gonna need the thermometer, all right, and for measuring the temperature of your H2O on your H2O. Now, you will read the direction and record the volume. So if this is, all right, 10 ml, 50 ml graduated cylinder, 25 ml graduated cylinder, they are asking you to place 7 ml, 24 ml, 17 ml, and 35 ml. I don't want you to just give me whatever it is on the direction. It's just an approximate and place on the flat surface so that you have to read the uncertainty of this instrument. Uncertainty is how much is it plus or minus what? When we say plus or minus, if it is, say, plus or minus 0.1, if this is the uncertainty of graduated cylinder, if this is the uncertainty of graduated cylinder, in the data sheet, let me see if I have the data sheet on part one. Let's see here. If you look at the data sheet, in terms of the data sheet, the volume they are talking about here, uncertainty, volume in the graduated cylinder, 10 ml. Low volume. Yeah? Somebody has, let me just have been muting. Let me mute somebody and mute themselves. All right, thank you. Volume, high volume is, if I'm starting with 7.0 or whatever you read, high volume will be plus 0.1, and this is 7.01. Low volume will be 0.1. You subtract 0.1 from there, and 7.0, all right, 7.0 minus 0.1. This is 6.9, 6.9. This is 7.1. I meant to say this is 7.1, 7.1 ml. This is 6.9 ml. That's what is meant by high volume and low interval. High volume and low interval. Of course, you can get the mass of each one of them. I wanted to point out what this high volume interval means. Low volume is factoring in the volume or the uncertainty of each class where you're going to be using 10 ml graduated cylinder, 50 ml graduated cylinder, 25, and 50 ml bigger. LML flask, LML flask, I don't know if that is feasible, but something similar to this. It looks like this. This is LML flask you're gonna be using to find the volume. I did this before, and student just didn't give me the calculation for the volume of water in 10 ml graduated cylinder, 50 ml graduated cylinder, and the rest of the glassware. This table 3, you need to have a prior knowledge on density. Remember what? Remember density equals to what? Density equals to mass over what? Mass over volume. All right. You don't need to change the volume to liters. Let's just get this out of our way. If I know the volume, or density, if I know density and I know mass, volume is given by mass over what? Mass or in grams of the density of water. Density of water. It turns out that the density of water varies from temperature to temperature, That is why you will need this. The thermometer is for measuring the temperature of your H2O, If you look here, why am I getting the temperature? So that you write the temperature or the density. You're gonna go to the table right here. If your temperature is 22, then the density is right here, okay? We're gonna be using this volume for, all right, the density. And once you know the density, you can find the volume and show the calculation. Don't just do it on your calculator and just assume that I'll figure it out, that this is how or this is what you did, all right? I want you to use the extra scratch paper to show your calculations, The rest is pretty straightforward. You may want to print out, the data sheet, and you will turn in, all right? If you don't have the packet, that is the handout for today's lab, it is posted on the modules. The handout I was just looking at, if you are wondering where I got that, you have to go to the modules and go to today's lab, which is measurement and uncertainty. It is posted in here under the modules. This is where you can download the direction. The data sheet I do have, it is published under the assignment. You're gonna come back to assignment. This is where you'll be turning in your work. Right now, I just published the data sheet for measurement. You can attach any additional work from your end, all right? You should have some tab saying assignment or submit on this side of the screen. There is somewhere here asking you, wherever you read it, you can save, you can take a picture of it, you can scan it and send it as a PDF, attach as a PDF through the canvas. Do not send me as an email, all right? I'll not create it. All work should be submitted through the assignment, okay? Folder on. And I'll put the rubric. I don't have the rubric right now. Rubric will tell you how the grades will be distributed in terms of, each section. For example, I may say 20 points for showing me the calculation. You don't show me how you arrive at the density or volume of your, the volume of your water sample. How did you figure it out that? Don't say that it's in my calculator. You have to show me the work. I'll see that, oh, she or he showed me the work, and you'll get full credit for what? For showing the calculation. I'll have rubric in all the data sheets so that you know why you don't get full points, or if you get full points, if you did your work, that's fine. Sometimes maybe somebody fails to write an explanation that, what do you think about this? And then somebody say, oh, I didn't see this. I'll write a comment in there that, okay, you lose partial or you get partial credit for not showing. So there'll be rubric on how the data sheet will be scored. You'll get a scorecard for that. Before we call it a day, I want to take a small poll. I'll stop sharing my screen for a moment and see if I have, hopefully it's gonna allow me to deploy, all right. All right, let's see if it's gonna, look like here. Since this seems not to be working on my end, I wanted to see if I can create a poll for us, see how we are doing with respect to the lab kit. However, my system is not, it's not allowing me to create a poll for us in order to you received your right, so all right. Anyway, just never mind about the poll. I wanted to run a quick poll on how many of us have received the lab kit. If you haven't, all right, if you haven't received your lab kit, please send me an email so that at least I'll get to know who needs extension for this lab. If there is no question, I will stop here today. We will meet Monday, all right? There will be a quiz, all right? There will be a quiz due on Sunday, every Sunday midnight. I don't want to rush you. I know, it's a fast-paced course. So I want every Sunday the lab data sheet as well as the quiz to be completed. So if you can get away, because if we split it until next week, you'll have two labs next week again, all right? So if you can get done by Sunday for this week's works, that will be fine. We'll be in good shape. However, I can give extensions those of you who have not received the lab kit. If you haven't received the lab kit, please send me an email and I'll take note of that. But if you have, I'll recommend that you get started right away and get the lab done. There will be a quiz, and I know the quiz will require you to use other resources. I'll send a study guide that you need to know this, you need to know this, so that you can use your lecture text and any other resource to prepare yourself before you click the link on quizzes tab on Canvas, all right? There'll be a quiz, multiple choice, I believe 25 multiple choice questions, which I want you to have an idea of what the questions are. There will be bullet points. You need to know the significant figures, for example. You need to know this and that. I'll send out the study guide for that before you get started, so that at least you have an idea of what you need to know before you get started. 25 multiple choice. If there is no question, that marks the end of our pre-lab lecture today. You are on your own. In case you have anything, please let me know. Thank you for joining in this morning. Hope to see you next week, same time. Somebody has a question. Where do we find the instruction? Yes, the instruction for the lab, Chelsea, the instruction for the lab is posted in the modules. If you go to, all right, if you go to modules on Canvas, you'll click the modules. The lab procedure or instruction are given in the module with the respective date, like today's date. Let me just share that. If I go to Chelsea, if I go to modules, did I share that? Let me see if I can share my screen so that you see what I'm talking about here. I'm going to share my screen. If I go to modules, Chelsea, look at this. I have module 1, which was this past Monday. I have everything right here. If I go to module 2, which is the day, June the 24th, next week, and so forth, so forth. These are the instruction or procedure. Unless otherwise changes, these are what I have for all the days we'll be meeting. You see this? Until module 11. These are the instruction. This is where you'll be getting instruction. And then the data sheet will be under the assignment. This is because you're gonna be turning in as assignment. You see all this? Right now, you can't see all this, but I can make available as you go along. For next week, I can make this available for next week. You can also see for next week, even the week after, you know. These are the data sheet where you have to download, work, write, attach any extra work that will help you. Let me just stop there. I hope I've answered your question, Chelsea. Did I answer your question? Are we together, Chelsea? Thank you. Yeah, so for everybody to be clear, that's where you find stuff. You don't know, I know you're wondering, where is the lab manual? Where will I get that? I do have mine here. I had to print mine, all right? I have to print mine right here. You see this? It's not for visible, but you can see that a little bit. Yeah, I had to print it out, but if you can read it online, that's fine. So they are all available online. You may want to print out the data sheet from the assignment so that you can use a pen and, you know, show your work. Please do not use pencil because I won't be able to see. They are not visible from my end. Use ink. If you make mistake, just cross out. Any other question? All right, if there is no other question, I'll end the lecture right now. Thank you for tuning in. See you next Monday. As I said, I'll send you the certificate for the quiz. Before you get started, I want you to have an idea of what you are getting into. Thank you. Be safe. See you next week.